In this video, we are going to look at finding the least common denominator of rational expressions. And this is really a lead-in to when you're going to be asked to add or subtract rational expressions, which can be tricky. And the key to being successful at those is finding the least common denominator. So I'm sure you've heard least common denominator before, and you've probably had to deal with least common denominator when doing something like, 1/5 plus 1/3. And if these two numbers, 5 and 3, don't have any factors in common, one quick way to find the least common denominator is just to multiply these together and get 15. And some of you may have even gotten into the habit of doing this all the time for any time you have fractions. And it will work. If I've got 1/12 plus 3/8 and I want to find the least common denominator, I could certainly do 12 times 8, although it is not going to be the least common denominator in this case. It's going to be a common denominator. What would that be? 96. And so, I could multiply this by 8 over 8, and then I could multiply the 3/8 by 12 over 12, and I would have a common denominator of 96. And then I would be able to add these fractions together. Now this video is not about adding these kind of fractions together, so I'm not going to do that. But I'm going to try to convince you that in the types of problems that you're going to be asked to do in an algebra class, when you're finding the least common denominator of rational expressions, meaning there's variables in there, there's trinomials and binomials, they're not just numbers like this, finding the least common denominator is going to be super important. If you don't do the least common denominator here, no problem, right? You just reduce it at the end, not a big deal. If you don't find the least common denominator when you're doing rational expressions, you're going to end up with, stuff to the 4th power or 5th power. It's just going to be ugly. It's going to make it really tough to finish the problem. So, if you haven't made it a priority to find the least common denominator when doing simple problems like this, let me go through how you would do that by just looking at this 12 and this 8. Okay, so we want to break this down into its smallest prime factors. Okay, so 12 is 2 times 2 times 3, and 8 is 2 times 2 times 2. So when you're finding the least common denominator, what you want to do is look at these factors and you want to see what do they have in common here. All right, so they both have this 2 right here. So I'm going to pair those up and I'm going to make a factor of 2 in my least common denominator. And then look at that. There's another 2. Okay, so I'm going to put another 2 in my least common denominator. Now, they don't have anything else in common. The 12 has a factor of 3 left and the 8 has a factor of 2 left. So I have to have this 3 represented in my least common denominator, and I have to have this 2 represented in my least common denominator, and I multiply all those together, times, 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 and I end up with 4, what do I have, 12, 24, which makes sense, right? 8 times 12 is 24. Now there's multiple ways to do the least common denominator with just numbers like 8 and 12, right? You could write all the multiples out. There's other one of my favorite little ways is to go like this and then pretend like you're dividing and say what's the biggest number that goes into 8 and 12. That would be 4. And then 8 divided by 4 is 2, and 12 divided by 4 is 3. And then multiply these together. 4 times 2 times 3, and that is 24 as well. I like that little way. It's kind of fun. But this method over here is not really going to work great for rational expressions, which is the focus of this video. The method that's going to work best for rational fractions is this guy right here, okay? Writing out the factors of each, factoring them, seeing what factors they have in common, okay? So if they both have a factor of 2, you can just write that 2 once in your least common denominator. They both have a factor, another 2, you write that. And then whatever factors they don't have in common must also be represented in your least common denominator. That's the easiest way to do it for a rational expression. So let's do one of those without further ado. And we're not going to actually do the adding in this video. I'm going to save that for another video. We're just going to practice finding the least common denominator. So the directions might say find the least common denominator for the two fractions. So let's say we have, so it doesn't really matter what's in the numerator because we're just going to do the denominator. Let's say we have 3 over 25m to the third. And then my second fraction, negative 9 over 10 m to the fourth. All right, so already you can see that it's getting a little more complicated than just the 12 and the 8. Remember the technique. We're going to write out the factors, okay? So the factors of 25 would be 5 times 5. And I mean the prime factors. Don't write like 1, 5, 25. Break 25 down into its prime factors, 5 times 5. And then m to the third is m times m times m. Now, you'll start to see you don't have to do this m times m times m thing when you get good at this, but for now, let's write it out. So 10 is 2 times 5, and then m to the fourth. Okay, so let's get rid of this here. So my least common denominator, I'm going to build that using the factors of each of my denominators. And I'm going to see what factors do they have in common. So I already noticed they have a 5. Did you notice that? They both have a 5. So I'm going to put a 5 in my least common denominator. And they both have m times m times m. They both basically have an m to the third. So that's going to go in my least common denominator. So now what do I have left? Well, I have this other 5 over here I haven't used, so I have to put that in there. I have this 2 I haven't used, so that has to go in there. And then I have this m that I haven't used, so that has to go in there. And then I'm going to multiply all this stuff together. Multiply, multiply, and I end up with 5 times 5 is 25 times 2 is 50, m to the fourth. And that would be my least common denominator, okay? So when you finally get to the adding part, you know, when you have to add these two fractions together or subtract them, you'll have to figure out what you're going to multiply the top and bottom of each fraction by to get the least common denominator. And that's going to end up being the stuff that they didn't have in common, right? So what did they have in common? They had the 5 in common, and they had the m to the fourth in common, or the m to the third in common. So over here, this first fraction had a factor of 5 that this guy didn't. So that's what you would end up multiplying by. You'd end up multiplying this fraction by 5 over 5. No. What am I messing up here? That's not right. It wouldn't be 5. We would just need a 2. Oh, it's the other guy's stuff. Okay, scratch that. So this guy has a 5 that this guy doesn't have. There we go. So we want to multiply this second fraction by 5 over 5 because he didn't have the 5 that the other guy, the first fraction, had. So then, see, that gives you 50m to the fourth. And then my second fraction had a factor of 2 and a factor of m that the first fraction didn't have. So you'd have to multiply the first fraction by 2m over 2m, and that would give you the 50m to the fourth in the denominator. All right, so that's in a different video when you actually go and add them together, but that's what you would have to do next after you find your least common denominator. And if you want to see that, I have a playlist called Rational Expressions, and in that there should be a video called Adding and Subtracting Rational Expressions. All right, let's try another one. Let's say we've got, I have about 4 more examples I'd like to do because these really can get different. There's lots of different types. So let's say we have 14 over 27x to the third, and then 8 over 9a minus 45. So here's my first minus I have here. Sorry, that's my printer if you can hear. It's a loud printer. So we need to think about how we're going to factor something if it's a binomial. And that's a little different. So then we got to start thinking about greatest common factor, and then eventually we're going to look at trinomials. We have to factor trinomials, and all of our factoring skills are going to come in handy here. So the first step is to factor each denominator. Factor the denominator, okay? So over here I just have one term, 27x to the third. So to factor that, I just write out the factors. So 27 is 3 times 3 times 3, and x to the third is x times x times x. Now this guy, 9a minus 45, that's a binomial, so I have to think about the greatest common factor, which in this case is 9. So I could take that 9 out, and then I'd be left with a minus 5. Oh, I'm sorry. Let's make these the same variable. This should be an x. They should either both be x's or both be a's. Let's go with x. All right, so this would be 9x. And so if I take out that 9, I'm going to be left with 9 times x minus 5. And of course, 9 is 3 times 3. So the factors of my first fraction denominator are 3, 3, 3, x, x, x. The factors of the second fraction's denominator are 3, 3, and x minus 5. X minus 5 itself is one factor. So when you write your least common denominator, you're going to first write what they have in common. All right, so what do I see? I see a 3 times a 3 and a 3 times a 3. That's 9. And then this fraction over here has got 3x to the third, so I'm going to have to put that over here. And this fraction has a factor of x minus 5, so that also needs to go in my least common denominator. So my least common denominator is going to be 27 x to the third times x minus 5. When you're going to be asked soon to add these fractions together, then you would have to figure out, what do I want to multiply this fraction by to get my least common denominator? And it's going to be the stuff from the other fraction that wasn't shared, which is this 3x to the third business. And to multiply this fraction over here, top and bottom, you would multiply by the x minus 5, what the first fraction's denominator did not have, what factor it didn't have. And you'll notice now each denominator would multiply to be 27x to the third times x minus 5. And then you'd still have to finish all this addition, which, like I said, is in the other video. But if you're just asked to find the least common denominator, this is your answer right here. What is the, oh, sorry. My pen got a little out of control there. This is the least common denominator. Okay, let's try another one. Find the least common denominator. Basically, this really relies on your factoring skills. You have to be good at factoring. Let's do one with 3 fractions. That sound exciting? It's going to be the same idea if you have 3 fractions. So say we have 13 over r squared plus 7r, negative 6 over 5r plus 35, and negative 7 over r squared plus 14r plus 49. So in the future, in the near future, you're probably going to be asked to add or subtract these, and you got to find the least common denominator. So first step is to factor each denominator. Here I have 2 terms. Always look for a greatest common factor, and I see here I can take out an r. And that'll leave me with an r plus 7, and those are the factors of that denominator. Alright, second one, what do you see? We can take out a 5, right? And that'll leave us with r plus 5. And so I have 2 factors of that denominator. Next one, I have a trinomial. I have 3 terms. Now the first 2 terms have an r in common, but to do a greatest common factor, all 3 terms have to have a common factor, and we don't have that here. What we have is what I like to call an easy trinomial, because the a value, or the lead coefficient, is 1. So we know this is going to be r times r to give r squared, and then we just need to think what multiplies to be 49 and adds to be 14, and that would be 7 and 7. It would be positive 7 times positive 7 is positive 49, and it adds to be 14. Again, really relying on your factoring. If any of this factoring is confusing, you should go watch some of the videos in my factoring playlist, and it goes through all these different kinds of factorings. Alright, least common denominator. This one's going to be big, because we got to look at all of our factors. Do they have any factors in common? Wow, they don't. They don't have any factors in common. So basically, we have an r plus 7 and an r plus 7 here. So those have a factor in common. So when you have 3 of them, you can, let's see, let's write it out this way. Let's put the factors of, let's put the red factors down here like this. Here's another way to think of this. You might like this way too. Every every denominator's factors have to be represented in the least common denominator. So let's start with the red stuff. We'll just put the red stuff in the denominator. Now let's go to the green stuff. I need a 5. Do I have a 5 down here? I don't. Okay, so I'm going to have to put a 5 in here. Do I have an r plus 5? No, I don't. So I'm going to have to put an r plus 5 in here. Now let's go to the blue stuff. So here I have an r plus 7 and an r plus 7. I need 2 factors of r plus 7. Well, I already have one factor of an r plus 7. This is that whole sharing thing. So I can use this factor of an r plus 7. I can share it with the red. And I need another factor of r plus 7. So if 2 of the denominators share it, you could write that down as something that's shared. It doesn't have to be shared by all 3. And then you can list all the other factors. So that is the least common denominator. That is one ugly least common denominator. If I were to write this out a little nicer, I'd put the 5 in the r first, and then the r plus 5, and then the r plus 7. Since there's 2 of those, I would write that as r plus 7 quantity squared. Wow, that was a doozy. I would hate to finish this one with pluses or minuses, but that is the least common denominator. All right, let's try 2 more. This next one is a short one, but it has kind of a trick in it that I want to show you in case you see it. It's really a simple problem if you know what to do, but if you don't know what to do, it can be really confusing. So let's say you have 2 over x minus y and negative 7 over y minus x. So these denominators cannot be factored. There's nothing to do. And so you might think, well, my least common denominator is just going to be x minus y times y minus x. And you could do the problem like that, but it's going to be more complicated than it needs to be. Here is the trick. These 2 factors are not quite the same. Remember, if they're the same, you can just write it once. But they're really close, all right? They're off by, they're switched, right? And subtraction is not commutative. So these 2 things are not equal if you switch them. But if you multiply one of these guys by a negative 1, so let's say I take negative 1 and multiply it by y minus x, I get negative y plus x, which is the same as x minus y. So x minus y is not the same as y minus x, but x minus y is negative 1 times y minus x. So what you can do here for your least common denominator is make your least common denominator negative 1 times one of these 2 things. It really doesn't matter which one. Let's go ahead and say my least common denominator is negative 1 times y minus x. Okay? Now, what is negative 1 times y minus x? Well, negative 1 times y minus x, like I showed over here, is x minus y. So your least common denominator can be x minus y. If I were to add these 2 fractions together, I wouldn't have to do anything to this first fraction, and all I would have to do to the second fraction is multiply by negative 1 over negative 1, and that would change this denominator to x minus y. Okay, so when you see 2 factors that are almost the same, but they're reversed, and it's a subtraction, you can just multiply one of them by negative 1, and you'll end up with the same factor over here. You don't have to write the factor twice. Okay, that could save you some headache. All right, last one. Last one. You might want to try this one on your own if you haven't done that yet. Stop the video and give it a try. Let's say we have 17 over x squared minus 5x. And my second fraction is x plus 4 over x squared minus 2x minus 15. All right, what is the least common denominator? If you want to pause the video and give it a try, go ahead and do that now. All right, so number 1 step is to factor each denominator. Here I just have a binomial, 2 terms. There's a common factor of an x there, so I'll take that out. This guy is a trinomial. It's an easy trinomial because it just has a leading coefficient of 1. So I know this is going to be x and x, and I have to figure out what multiplies to be negative 15 and adds to be negative 2. Sounds like negative 5 and positive 3 will work. Alright, what do these guys have in common? Well, they both have a factor of x minus 5 in common. So that's going to go in my least common denominator, x minus 5. And what do we have left? We have a factor of x over here, and then we have a factor of x plus 3. So that would be my least common denominator. If I were to have to add these fractions together or subtract them, whatever, let's say, in the next section you're going to get a problem like this, then what you would want to do is leave it in its factored form and just multiply this one. Let's use blue. We would multiply this fraction by what it's missing, which is the x plus 3 over the x plus 3. And you'd multiply this fraction by the factor that it's missing, which is just the x, right? Just the x. And you'd end up with that. And then you wouldn't multiply all this stuff out on the bottom. You could leave it factored. Like I said, watch the next video on adding and subtracting rational expressions, and that should help. But getting the least common denominator is really the key to getting off on the right foot on these tricky problems.